Okay, so welcome to the introductory video for pre-calculus and trigonometry. Uh, what I'm going to be talking about here is just some general basic ideas about trigonometry and to get you started with getting prepared for pre-calc. So what we're going to start with is trigonometry studies triangles. What I have here is a basic equilateral triangle, which we'll describe as a 2-2-2 triangle. Now, if you remember back from your geometry class, you can, if all three sides are the same, then each angle will be a 60-degree angle. And you should also remember that you can split that in half, and when you split that in half, what you actually end up doing is splitting the base in half, and you split the vertex angle in half to create two 30, 60, 90 triangles. Now you should also remember from your geometry class the most basic idea, which is that a squared plus b squared will equal c squared, where c is the hypotenuse of the right triangle. So let's plug these in. I'll use 1 as a, so we'll say 1 squared plus b squared will equal 2 squared. And if I simplify that, I end up getting b squared equals 4 minus 1, or b equals the square root of 3. Okay? Now, an interesting idea here, basic idea here, is that if I was to scale this triangle up to say a 4, 4, 4 triangle, which I then split in half, and get a 30, 60, 90 with a base of 2 and a hypotenuse of 4, and I complete the same steps of 2 squared plus b squared equals 4 squared, I end up getting b squared equal to 12, or b is equal to 2 square root of 3. So by multiplying each side by 2, I end up getting the same type of relationship here. And what trigonometry does is it takes a look at three special relationships within a right triangle. Right? So here's a right triangle, and we will make this a 30, 60, 90. And we'll call this the opposite side, the hypotenuse, and the adjacent side, where I'm talking about this 30-degree angle here. So we have sine of 30, right? The sine of 30, which if you remember from your trig or from your geometry class, the sine is equal to the opposite over the hypotenuse. So in this case, my opposite here would be 1 over 2. If I look at the cosine of 30, which is the adjacent over the hypotenuse, I get 2, or sorry, let's go back. If I'm looking at this one, it's just a square root of 3 over the hypotenuse, which is 2. And if I look at the tangent of 30, which is the opposite over adjacent, I get 1 over the square root of 3, and we need to rationalize that. So we rationalize by multiplying by square root of 3 over square root of 3 to get the tangent of 30 equal to square root of 3 over 3. Okay? And that's true no matter which of these triangles I use. If I use the smaller one or the larger one, we simply get a fraction that reduces to be the same. For instance, let's go to where the opposite is 2 and the hypotenuse is 4. They're equal. Or adjacent was 2 root 3 over 4, which is equal. Or 2 over 2 root 3, which is equal to root 3 over 3. All right, so again, it doesn't matter how large these triangles get. No matter what, the tangent, the cosine, and the sine of 30 always remains in these constant ratios. And that's what we're going to be discussing. That's what we're going to be looking at in future videos, is this idea that the size of the triangle doesn't matter too much, that given an angle, the relationship between the two sides is always fixed, right? It is a constant number. So tangent of 30 is a constant number. It is always the square root of 3 over 3. The cosine of 30 is a constant number. It is always 2 root 3 over 4 or root 3 over 2, right? These ideas that these numbers are constant is the essence of what we're going to be working with trigonometry. All right, so the next video we'll explore that idea a little bit further. All right.